This conference will now be recorded.
Electric machine is dominating than IC engine. That's why people are motivating electric motors in vehicle application. So we understood why people are motivating towards electric machine. We understood. After that, here what are the application? What are the types of electric vehicles are available in market? Where is the scope for doing the research? Each and everything we can understand by using this slide. Generally, electric vehicles are classified into three parts. One is, this is called pure electric vehicle, battery electric vehicle. Hybrid electric vehicle is nothing but combination of electric motor and IC engine. Both the drives are available. Fuel cell electric vehicle. Still, there is a lot of research is going on this fuel cell electric vehicle. Basically, compared to other two types of electric vehicle, fuel cell, it is very expensive. It will take time. Still, a lot of research is going on this topic. That's why here there are so many challenges are there. Fuel cell cost, fuel processor, fueling system. These all are the major issues. That's why the applications of fuel cell electric vehicles are less compared to pure electric vehicle and hybrid electric vehicle. If you take the battery-based electric vehicle, these are the major issues. Managing the power in the batteries, next charging facility. These are all the challenges in electric vehicle, pure electric vehicle. One more thing is here, generally battery-based electric vehicle, they are adopting only for short range purpose, not for long drive purpose. Why? Because here for charging the battery, it may take more than 7 to 8 hours. That's why here they are not preferring for long drives. They are preferring for only short range distance. But if you take hybrid electric vehicle, you can go for long drive applications also. Only thing is, in case of hybrid electric vehicle, main challenges are there are two propulsion systems are there. Energy managing between the two propulsion system, it is not so easy. That is also main challenges. Next, battery sizing and managing. These all are the challenges in hybrid electric vehicle. In today's session, we'll try to put more concentration on what are the types of electric motors they are adopting in vehicle application. At the same time, what are the methods they are adopting to control the electric motors in vehicle application. We'll try to discuss. Right now, this is the complete overview of the electric propulsion system. Right now, come to these are all the main parts of the electric propulsion system: electric motor, power converters, electronic controller. I'm audible to you?
Yes, sir. Audible, sir.
Yes, sir.
Okay.
Yes, sir. You're audible.
Can you mute your mic? Someone is yeah, participants, I'm requesting to you, kindly mute your mic. Whenever you want to ask question, you can unmute your mic. You can ask, no issue. Right now, this from the main parts. This is a complete overview of the electric propulsion system. Now come to electric motor category. Under electric motor category, they are adopting DC motors, induction machine, switch reluctance machine, permanent magnet synchronous machine, permanent magnet brushless motor, permanent magnet hybrid motor. Please should understand, before 1970s, before invention of field orientation control method, they were using only DC motors in vehicle application. This is so important point, right? Before 1970s, there were no FOC method. FOC, the field orientation control method. This is the speed control method. This method they have proposed in 1970s. Before 1970s, AC drives applications are only limited in vehicle application. Before 1970s, they were adopting DC motors in vehicle application. Why? Because basically DC motor, because of commutation action, it will generate the torque instantaneously. By using DC to DC converter, we can control the torque instantaneously. if motor drive is DC. After invention of field orientation control method, the applications of these motors, induction machine, switch reluctance machine, PMSM machine, uh, all are AC machines. The applications of AC machines, it became popular after 1970s. Right now, come to power converters. Generally, power converter chopper circuit, they are adopting inverters. They are adopting this all the resonant converters. They are adopting in power with respect to converter side. Now come to electronic controller. Electronic controllers are classified into two parts. One is with respect to software side. Another one is hardware side. So what is the function of what is the main aim of software? Under software, there are control schemes will come under software category. Speed, control schemes. All speed control schemes will come under software category. Hardware side, DSP, microprocessor, microcontroller will come under hardware side. So participants, someone kindly mute your mic. So what is the function of this hardware? So whatever program you are writing, suppose under software side, there are variable voltage and variable frequency control method, field orientation method, vector control schemes, model reference adaptive control, self-tuning control method. These all are control schemes. So by using these control schemes, we can control the speed of the electric vehicle, right? So what is the process in a particular vehicle system? First they will decide the speed. This is called reference speed. Based on the reference speed, they will sense the actual speed. From the speed sensor they will sense. After that they will compare an error they will send to PA controller. Finally PA controller will generate the required torque, how much torque is required to meet the customer speed. That will calculate by this one combination of software and hardware. Both will calculate the how much torque is required to generate to meet the customer speed. That is the main task. So here, after generating this reference torque, how we are going to control the torque, actual torque, by using this reference torque? That is the big task for the electrical scholars. So what they will do, whatever reference torque is coming from the PA controller will decide how much reference torque, how much torque is required, how much torque you need to maintain your actual system to get your reference speed, right? So after obtaining this reference torque, here in various method, in field orientation method, they will control the actual torque in a different form. In direct torque control method, they will control the actual torque to meet this requirement. In other procedure, in case of model predictive control method, to meet the actual torque to the reference value, okay, procedure of the model predictive control scheme is different. Please start understand, don't get confused. This block diagram is common to all electrical schemes, all electrical drives. This block diagram is common. Only thing is, depends on the requirement, depends on the situation, yeah, depends on the customer requirement also. Yeah, they will select the different control schemes. So various control schemes are available in literature. Mostly they are adopting field orientation method, direct torque control method, model predictive control method. These methods they are adopting. These methods are so popular. That's implementation is easy. Dynamic response is also very fast. That's why they are preferring these methods in vehicle application. So by using this FOC method, DTC method, MTC method, what they will do actually, they will bring the actual system, actual mission torque closely to reference torque. That is the aim of this control scheme. Understood? Everyone clear? If it is, please study that. The aim of this control scheme is finally it will try to bring your motor torque, machine torque, whether it is DC machine or AC machines. Finally, they will bring the actual motor torque to closely to reference torque. Once actual torque is coming closely to reference torque, then you can expect the speed of the actual system. It is coming closely to your required value. That is the main aim of speed control of the. This is the procedure. This is happening now. Please try to understand. Whatever you are selecting the method, finally that method speed control scheme, you need to dump in the hardware. You need to execute by using this processor. Finally, this processor will execute, will calculate this, and finally it will generate the control pulse to power converter. If you take any method, whether it is microprocessor or microcontroller or DSP or FPGA or some X controller, finally from the hardware, the expected output is gate signal. This is called controlled signal. Controlled gate signal. This controlled gate signal is the input to the power converter. So finally, power converter, there is no option to the power converter. This is called power electronic module. Finally, power electronic module will obey the duty period of the switch. Finally, it will regulate the output voltage and frequency based on the customer demand. Output voltage and output frequency finally will apply to the electric motor. Then electric motor characteristics, torque speed characteristics will regulate based on your reference speed. This is happening in electrical propulsion system, right? So first, as your job is, your main motto is you need to understand the, as an electrical engineer, many of the scholars, they are putting more concentration on this topic. Some scholars, they are trying to putting more concentration on power management in the electrical propulsion system. Some scholars, they are trying to developing the speed control schemes in electric vehicle application. Some scholars, they are trying to working on this resonant converter, chopper circuit. These are all the major challenges. Scopes you can find in propulsion system. If you want, you can work on speed control schemes, or if you want work on this power circuit topology side, you can work. If you want, you can work, right? Machine side, machine designing, only a few people they are working. Very few people. If facilities are available, we can work on this topic. Otherwise, it is very difficult to work on the machine designing side. Machine designing side scope is very less compared to other areas, right? These are all the areas you can find. If you want, you can motivate it based on the your application, based on your requirement. You can motivate it towards as well. At the end, you can find your topic, right? In today's session, our main aim is we need to put more concentration. What are the methods? This topic already, what are the types of electric motors they're adopting in vehicle application, right? This topic, motor side as well as speed control scheme side, we'll try to put. This is the part one, this is the part two. These two parts I will try to highlight in today's session, right? Now come to applications of electric vehicle motors. So these are all the motors they were adopting. These all are DC motors. Before 1970s, they were using DC motors in vehicle application. After 1970s, they are adopting AC drives. Nowadays, please try to understand, no one is using DC drives. The applications of DC motors are almost exhausted. No one is using in practical condition nowadays. AC drives they are adopting. Why? Because there is so many features are there. After invention of power electronic module, power semiconductor, there is a lot of research is going on power semiconductor element side also. Next, there are so many processors also came with respect to hardware side. DSP, FPGA, high-end processors are available in market. By using processor, we can execute the even control algorithm is complex with respect to AC motor side. We can execute within the short period. That is the main advantage. There are so many factors are affecting towards why people are motivating towards AC machines. I will try to explain in today's session. right? So before invention of vector control schemes and some power electronic module schemes, they were using DC drives, DC series, shunt motor, separately excited machine. They were adopting. After that, they are using these machines in vehicle application. So here, the main advantage of the induction machine is maintenance is zero, cost is less. So what are the advantage of series machine? What are the advantage of induction machine, PMS machine, switch reluctance machine? Each and everything we'll try to discuss by using evaluation of the evaluation sheet. This is the score. This is called score sheet. Points for the how many points got DC motor with respect to power density. There are so many characteristics based on this character. Power with respect to power density, DC motors got very less, few points, only 5 points, but permanent magnet brushless DC motor got highest points. Right now, come to efficiency. With respect to efficiency point of view, PMS, permanent magnet brushless motor, and hybrid permanent magnet hybrid motor got highest point. With respect to control ability, this is the very important point. Why? Because in today's session, our main concentration is what type of motors they are adopting in vehicle application. That is the first objective. Second objective is how they are going to control the particular motor. We'll try to discuss in today's session. First objective, we can decide by using this slide. After that, we'll try to discuss what are the various control schemes are available in literature. What are the methods they are adopting? I will try to explain, right? So in today's session, our main aim is how they are going to control, whether controllability. With respect to controllability, if you verify, DC motor got highest point. For other machines, less. Nothing but DC motor control is very simple. This is the DC motor. All other motors are got less points compared to DC motor controllability characteristics. So this was the AC motors. Reliability point, with respect to reliability point, induction motor got highest point. HOT cost level also induction machine got highest point. You forget about other characteristics. Your job is you need to put more concentration on this point. Our aim is discussing on which basis they will select the motor. By using this evaluation sheet, we can understand. So by using this slide, we can understand DC motor controllability is superior than AC motor. Now that's why earlier days, before invention of power semiconductor elements, FOC methods, field orientation method, vector control schemes, they were using DC motors in vehicle application. Why? Because control is very simple. Control scheme is simple. At the same time, dynamic response of the DC machine is very fast. Why dynamic response of the DC machine is very fast compared to other machines? We need to discuss. Right now, next, this was the key electric vehicle technology. In today's session, we'll try to put more concentration on this electric motors. Our main job is understanding what are the types of motor are available in literature for electric vehicle application, on which basis they are selecting the motors. After selection, then how they are going to control the machine, we'll try to discuss in today's session. Now, next, before going to discuss controllability of the particular system, we need to understand some fundamentals. Once you are very strong in fundamentals, we can easily understand what are the control variables in electrical drives. We can easily identify. Without understanding fundamentals, very difficult, right? Next, one more thing is by using this slide, we can understand how many control variables are available for electric drives. We can understand what are the major control variables they are adopting. We can understand. Right now, by using this slide, we can understand. We can select control variables. Right now, what is the main function of motor generally? This is the fundamental slide. Right. By using this slide, we can understand the control variables. One of the control variables in electrical drive. That is the main aim of this slide, right? right? Next, come to what is the main function of electric motor? The main function of electric motor is it will convert electrical force to mechanical force. This is the input. This is the expected output. What is the name of this voltage? This is called potential element. By using this potential element, we can do electrical jobs. What we can supply current. This is called kinetic element. Similarly, with respect to torque, with respect to mechanical side, this is called mechanical side. With respect to mechanical side, torque is called potential element. By using this potential element, here what we can do with respect to mechanical side, we can change the speed or we can change the position of the shaft. If you want to change the speed or if you want to change the position of the shaft, here with respect to mechanical side, you need to put more concentration on the mechanical potential element. You need to control. That's why torque you have to select one of the control variable for changing the speed or position of the shaft. So here you have to give as a research scholar, as an electrical scholar, while controlling the speed of the electric drive, you need to put more priority. You have to give top priority for the torque production, torque control, nothing but torque control of the torque is so important in electric drive system. That's why here this is the one of the control variable. Torque is so we have identified the one control variable. How we can control the torque practically? Torque we can control by using the variable voltage and variable frequency if it is AC machine. Otherwise, if it is DC machine, by using variable voltage concept, we can control the torque. Torque we can control by electrical potential element. There is no another option. Please try to understand. Torque is function of the electrical parameters as well as mechanical parameters. That's why here by using this electric potential element, we can control the torque. Understood? So here finally, by using this slide, we can understand. If you want to control the speed of the shaft or position of the shaft, there is no option. You need to control the torque. This is the mechanical system. This is electrical system. In electrical system side, by using voltage, we can change the amplitude portion of the current. Similarly, with respect to mechanical side, by using the torque component, we can change the speed or portion of the shaft. That's why you need to give top priority for the torque controller. Torque is the one of the control variable in electric system. So here, what is the second variable? That is the question now. Finally, in electric drive system, they are taking only two control variables. One is torque. What is the another one? Anyone from the participants? Please tell me what is the second control variable in electric drives. So whatever concepts we are discussing, all concepts are common to all electrical drives, DC drives as well as AC drives. Please tell me. Okay, what is the second control variable in electric drive system? One is torque. What is the another one?
Current.
No. Anyone? Anyone from the participants?
It will be a flux.
Very good. It is a flux. These two are the control variables for all electrical system. Even if you take field orientation control or director control method or model predictive control method, if you take any control method, finally they are taking, even in case of DC machine, these methods are applicable for AC drives. Even if you take DC motors also, they are taking torque and flux as a control variable. So here, by taking torque as a control variable, what is the benefit? We can control the speed and position of the shaft. Right? With respect to control variable 1, we can give justification. Now, why flux they are taking as a control variable? By using another slide, I will try to explain. Then only you will understand. By using mathematical expression, I will try to give justification for the second control variable. Right? So to give the justification for the second control variable, for understanding purpose, I will take universal torque expression. So by taking the standard mathematical expressions, is Zr sine delta. This is the standard mathematical expression. This expression is common to all electrical machine. This equation is applicable for DC machine as well as AC machine. Right? So where Zs is the stator flux, Zr is the rotor flux, delta is the space displacement angle between the two vectors. So now this equation we will try to adopt to DC machine. In case of DC machine, this is field flux. So this is armature flux. Armature flux is always in phase with brush axis. Field flux is always in phase with pole axis. At any instant of the time, irrespective of the operating speed, irrespective of the operating load condition, the space displacement angle between the stator flux, this is called stator flux, this is called rotor flux. Delta is always 90 degrees. That is the beauty of commutation action in DC machine. Because of commutator, okay, we can maintain space displacement angle is always 90 degree. If it is 90 degree, then what is the advantage? This one, the Stark equation becomes Is Sir sin 90, it becomes 1. So with respect to torque controller, while controlling the torque, you need to take care about how many number of state variables are involved in the torque expression. As an electrical scholar, before going to control the electric drive, you need to understand, you have to extract the mathematical expression, modeling equation of the torque expression of the particular system. Let us assume that here, based on the concept, if you apply this equation to DC machine, this finally, so here how many number of state variables are involved in the torque expression for DC machine? Delta, it is not a variable. Delta is a constant in case of DC machine. If delta is 90 degree, then the torque equation becomes second order. So here, next one more important thing is, if you want to improve the torque profile, if you want to improve the dynamic response of the speed or position, here first condition is torque equation should be linear. It should be in first order condition. It should be stable position. How if it is first order, automatically your equation become linear. Just at the same time, forcefully it becomes stable. So this one, what they will do, solving the torque forcefully, they are trying to adopt armature voltage control method. Armature voltage method they are adopting. By using this armature control method, we can maintain stator flux as a constant. Magnitude we can maintain constant. If stator flux is constant, in armature control method, what we are doing, we are trying to maintain field current as a constant. If field current is constant, then stator flux we can maintain constant. So here, after adopting armature control method, what is happening with respect to torque equation? Torque equation becomes stator flux. It is not a state variable in case of armature control method. In armature control method, their aim is trying to maintain throughout the operation, while controlling the speed, they are trying to maintain field current as a constant as well as field flux as a constant. If field flux is constant, then your torque equation, it is depends on only Zr. Torque is directly proportional. Zr is directly proportional to Ia. So how many number of state variables are there? Finally you got only one state variable. Torque is depends on only in case of DC machine. After adopting armature control method, torque equation become linear. This is called linear condition. It is in first order. So the advantage is, if you want to control the torque, you need to regulate the Ia. By regulating the Ia, there are so many methods are there. Armature control methods are available in literature by using power electronic module. By using PA controllers, we can regulate the Ia for very fast by regulating the IA, by controlling the IA instantaneously, we can control the torque instantaneously. In case of DC machine, after adopting armature control method, your torque equation become linear. This point you cannot find in the textbook. By doing practice, by conducting experiments, you will understand. Otherwise, very difficult to understand this concept, right? Whatever we are discussing these points, they will not highlight in the textbook. Only by doing practice, by conducting experiment, you will understand, right? So here, by taking this equation, we can conclude that if you adopt this equation for DC machine, finally, after adopting armature control method, before applying armature control method, your torque equation is in second order. It is in nonlinear mode. It is in nonlinear conditions. By using nonlinear conditions, very difficult to improve the torque profile, right? So if you want to control the nonlinear torque, how many feedbacks are required? There are two state variables are there. You need to take two signals. You need to sense the ZSAR information at instant to instant. It is very difficult. Number of PA controllers are increases, then control complexity become more. Next, burden on the processor is increases. Computation. If computation time is increases, you will lose accuracy. That is the problem with nonlinear systems. That's why here what they are doing is they are trying to adopt armature control method. They are trying to adopt armature control method whenever they want to regulate the speed below base speed. That is happening whether it is DC motor control or induction machine control or PMSM machine or switch reactance, any machine. They are trying to adopt armature control method whenever they want to control the speed below base speed. Right? If they adopt armature control method, then with respect to DC machine, your torque equation of the DC motor become first order. If it is in first order, then dynamic response is first. That's why with respect to this point, with respect to controllability, DC motor got highest point. Why? Because how they will decide the points. This is evaluation. This is score sheet of the electric vehicle motors. Based on this, based on the torque profile, what is the origin for this? What is the origin for the controllability marks? The main, what is the reference? Reference is torque expression. Based on the torque expression, they will give this, they will assign the evaluation point for the controllability. Controllability is more, strength is more for DC motors. Why? Because torque is in linear mode. It is in first order. Right? That is the main advantage of DC motors. Now come to same equation. The same equation we'll try to adopt for AC machine. Here we are having limited time. So what I will do is I will try to explain only for induction machine.